Today, we're continuing our journey into learning Forge, and we're starting the third module out of this Getting Started with Forge learning path. And we're focusing on working with data in Forge. So by the end of this lesson, you're going to be able to fetch data from the Atlassian REST APIs using Forge API, you request Jira, request Confluence, request Bitbucket, and request Graph, store and retrieve data using Forge storage APIs, and make calls to external APIs securely. So why does data matter in Forge apps? So before a Forge app can be truly useful, it needs to work with data. For example, by pulling information from your Jira work items, saving a user's preferences, or integrating with third-party services. Knowing how to retrieve, store, and update this data is key to building useful apps. And this is very, very important, folks, because you don't just want your app to be alive in that session. Users are going to come back. And so you need to store the data. You need to be able to hold and retain values in between sessions. And so this is very, very important. Something that I've been trying to figure out for a couple of years now, because as I started to try to build a Forge app myself, we needed to retain data. We needed to retain data that wasn't necessarily in a Jira work item. And so you kind of need like a database, if you will. So I'm excited to learn how Atlassian recommends you do this. So for example, you're going to want to display details from a Jira work item inside of a custom panel, or store a user's input from a form, or call an external service to get live data. Let's look at how you can do all of this using Forge's built-in tools. So let's start off with fetching data from the Atlassian cloud. When you build apps with Forge, you'll often need to retrieve information such as work item details, page content, or repository data from apps like Jira, Confluence, or Bitbucket. Forge makes this possible by providing built-in methods to call Atlassian's APIs directly. These methods handle authentication automatically and respect the permissions defined in your manifest YAML file. How you access these APIs depends on where in your app the request is made. So from the backend, your app's resolver functions, use the @forge/API package. This is the most common and flexible method and supports calling Atlassian REST APIs as well as external APIs. From the front end, your app's user interface, you can't call APIs directly. Instead, you're going to use the @forge/bridge package to invoke backend functions that then do the actual API work using Forge API. Here are the main types of API requests you can use in Forge. So we have Jira API requests, Confluence API requests, Bitbucket API requests, and GraphQL API requests. To use those, you need to import the Forge API package in your app using import API, comma, curly brace, route, curly brace from, and then the Forge API. So I'm going to look at an example, but before we go there, let's look at what we're looking at here. So we are looking at request Jira. And so this is just a bunch of documentation for what you can do when you're trying to get data from Jira, from Confluence, from Bitbucket, and then from GraphQL. So this is okay, but just one little thing I want to disclose is when you're looking at this documentation, especially those 4 links that I just opened up, there's a fundamental gap between the example that you'll see here, right? This little data here, and like you see a little bit of a, just some static code here, templatized code really, if you will. But like actually looking at an example, right? This is where things get hard because these are just they're just getting your feet wet, right? They're just teasing what's possible, but at like 1/100th of what's actually possible. That's usually where I have a problem with documentation, which is why you're going to want to subscribe to the channel, because this is what this is going to be all about, right? We're going to drop videos that bridge those gaps, that take you from that little tiny example, that little excerpt of text, and then give you something actually valuable and useful. So make sure you hit that subscribe button right now. All right, so let's continue. So to use the request Jira call API, you're going to use request Jira when your app needs to read or update Jira work items, projects, or boards. For example, if your app contains a custom panel in a Jira work item that displays the title and the status of another work item, you're going to import the library. You're going to set up a variable. This const response is a variable. And we're going to do this request Jira. So we're basically telling it, bring me the items, the data that's in issue 1, 2, 3. Then you're going to have this const data, which is awaiting the response. I think this puts this response in, it takes part of this into this variable, and then it goes and grabs the response and puts it into the JSON. Then you're going to get the data, right? Dot fields from this JSON. That's part of this response, which is part of this 1, 2, 3. And you're going to get the summary, and then you're going to do the same thing for the status name. And so you're going to get the status that way. Then if you're in Confluence, it's going to be very similar things. So as you can see, you can get the title of the page, and then using this body.storage value, you're going to get the page content. And so again, the purpose of these things is to just show you what's technically possible, but again, 1/100th of what's actually possible. But it's just enough to get your feet wet, just enough to get you introduced and comfortable. But then you got to read through the documentation and you got to spend hours kind of figuring out what else can I do, because there's a million things you can do. And this is just showing you like one of those million things. We have something very similar for Bitbucket here. And then as we go down to GraphQL, we also have a GraphQL one here. Now, I am not 100% sure what GraphQL is. I have an idea of what the graph is, but I think this is more related on what Atlassian is doing with Teamwork Graph, right? And this is just like an interweb of interconnected data. So I have never played with this, but I'm quite surprised that this is available, and I'm going to be spending more time learning this GraphQL stuff, because I do know that Atlassian is investing heavily into this. But yeah, the GraphQL is particularly useful for applications performing complex data queries and mutations across Atlassian apps like Compass, or fetching data from different apps all at once. For example, you can show you the title of a Confluence page in the Jira work item link to it. So you can go grab it from the graph and you can grab all the data. So this is cool. All right, let's get into storing and retrieving data. So managing data storage is essential for app functionality. Forge offers storage APIs that allow you to store and retrieve data securely. Data storage is essential for most Forge apps, whether you're saving user settings, caching external data, or persisting state across sessions. And that's what I was talking about earlier, right? Where when your user is doing some interaction with your app, they go away or they go do something else, they come back, the data still needs to be there. So that's that persistent state. Hi, I quickly wanted to interrupt your video to let you know about something big that I've been working on. I'm working on the Big Book of Atlassian, and this is going to be given exclusively away to attendees that show up to the Atlassian Builders Summit happening October 22nd through the 24th in Long Beach, California. This is a completely free event, a completely free book that you can only get if you come to our in-person event. This is something that's super awesome. I am really happy to be putting this together. You can only get this in person. So make sure that you attend our very free event. All you need to worry about is your travel accommodations. We do have discounts for hotels. Use that link down below. Sign up for the Atlassian Builders Conference, and I hope to see you in October, and come secure your free copy of the Big Book of Atlassian. I'll see you in October. Forge provides several storage options depending on the complexity and structure of your data. Forge supports 3 main types of storage, each suited for different use cases. So we have something called key value storage. Key value storage, this is the most commonly used and simplest form of storage. It lets you store and retrieve values using string keys. It's a great for simple data like flags, preferences, or counters. So an example is store a user's preferred currency setting for a budgeting app, where the key is currency and the value is GBP. We have a custom entity storage. If you need to organize data around custom data structures, you can use this store API to define and query structured records. This is a more flexible alternative to plain key value storage. So for example, in a cat adoption app, store adoptable cats and filter by attributes like age, breed, or compatibility with children. This is something that I would want to use. And then we have Forge storage with SQL. So for complex relationships or queries, Forge lets you provision SQL database instances to store complex data sets. This is suitable when your app needs to manage structured data with relationships such as logs, transactions, or hierarchical data. For example, in a racing analytics app, track Formula One car telemetry data, including speed, lap time, and tire degradation for each session. So my 2 cents is you're probably going to be on the custom entity storage or the Forge storage with SQL. The key value, I think, is too simple, too primitive, but again, to explore which one's right for you and your team. Now let's talk about key features of Forge storage. Forge provides secure, scalable storage options that make it easy to store and retrieve data across app sessions and environments. In addition to saving data, Forge storage includes built-in features that make app development easier and meets the needs of larger organizations. So we have data residency. So your app's data is stored in the same region as your Forge app, aligning with Atlassian data residency commitments. This helps organizations meet compliance and governance requirements, especially in regulated industries. We can also partition by tenant and environment. Each Forge app instance has its own isolated data space. That means data is automatically partitioned by the site where the app is installed. Data is also scoped to your app's environment, such as development, staging, or production. And this separation reduces risk and ensures that data development never leaks into production. Then we have security and durability. Forge ensures that your stored data is encrypted at rest and in transit. The platform also replicates data across multiple availability zones for durability and resilience. This safeguard means that apps can rely on Forge storage for critical functionality, such as persisting app state, storing user preferences, and caching external data. Want to see how to interact with storage through code or CLI? You'll find examples and deeper technical guidance in the Forge Storage API reference documentation. So this is going to be one where you're going to want to go and see how all this works. So um, keep in mind that when you're looking at storage here, we're talking about, basically a database. All right, let me close some of these out and let's continue down this journey. All right, so this brings us to the end of this particular little module here. And let's see what we learned. Sergio is developing a Forge app that needs to display the status of a Jira work item on a custom dashboard. True or false? Sergio should use the request graph to retrieve the work item status in Jira. So this is just Jira. So I'm going to go false. I think you can just use, I think it'll work. I think it might be true, but I would use the request Jira instead. Yeah, because request graph is used requiring Atlassian's GraphQL APIs, which are limited in scope and not intended for retrieving Jira work item data. Yeah. All right. Natalie is developing a Forge app that will be used across multiple Atlassian sites. The app needs to remember site preferences. True or false? Natalie will need to write logic to search for the data and with an individual site herself. Needs to move. The app needs to remember site preferences. Natalie will need to write the logic to search for the data associated with. I'm going to say true on this one. No, this is false. Data in Forge hosted storage is isolated by site, so data from other sites will not be accessible when the data. Okay, so then apparently you can't do this at all. Interesting. Good to know. So general rule of thumb here, then, my takeaway would be, when you make your app, it's only going to talk to that specific site, so that URL. So don't expect to go across different sites. You might need to do like sync tools and stuff like that. That's kind of weird. More advanced. All right, so that brings us to the conclusion of how to work with data in Forge. Make sure you hit that subscribe button, drop a like, and come back because we're going to jump into create rich user experiences in Forge next.